Alright, welcome back to Ox Tools. Couple changes here today. This is going to be the first video with the new 1080 HD video camera I just got. So now I have two cameras, so one will be a lower resolution and then I'll have the HD camera for the fancy stuff. And we can get some different views of some of the action going on here. So today we're going to start a project. I've been waiting for something to show up that I ordered from a company in Washington or Oregon. It's a company that makes custom tie-down straps and ratchet straps and stuff like that. Anyway, I mentioned in a video a couple of videos ago about the problem with lifting gas cylinders up into the welding machine. The MIG welder and the TIG welder. So you got this big gas bottle and it weighs 200 pounds or whatever it weighs. It's too heavy, okay? And so I figured out a lift that I want to build. And the interesting part that the original idea has morphed and changed into a similar principle, but a very different configuration. I guess that's what I want to talk about. And I'll show some of the sketches, my initial, what I call a chicken sketch, where I'm thinking about it. And then I did a little layout just to work out some of the geometry in AutoCAD. And so now that this custom strap showed up, it's not really that custom, it's just a custom length is all it is. I'm kind of ready to start building it, which will be of interest to you guys and everybody out there, because anybody that's had to bear hug one of these bottles and lift it up and then, it's a nut buster, okay? So it's just not cool. And there's some commercial things on the market, but it's a good project if you have a metalworking shop. Simple to put together, nothing high tech, and just kind of normal stuff. So let's get going. Let's suit up and let's go. All right, let's open up the box here. See what we got. Not much better than a box showing up in the mail and something that you've been waiting for. Let's see what we got. Okay, so there's the strap that I ordered. And so this is a heavy-duty strap here. And you like the logo on the strap. I wanted polyester webbing, because it's low stretch. And so all they had were these patterned, polyester straps. So I said, okay, what the heck? I'll just get that. And then here's the ratchet guy. Now this is probably going to come off. I'm just going to remove this bolt, and then it'll just be mounted permanently to the lift. So. Yeah, okay, this is looking pretty good. All right, so let me show you some sketches and we'll go from there. Okay, so I just wanted to show these chicken sketches here and how the whole thing kind of started out. So when I started thinking about it, I was like, geez, well, what would work, right? And so we need to lift the bottle up, roughly 6 or 8 inches. And so what I was envisioning was some kind of, foot pedal, some kind of foot pedal type device where you stepped on it and it raised the bottle up like so, and then you could just bring the bottle off onto the welding machine. Well, I started thinking about this and thinking, it's kind of complicated, and then you're going to need some kind of locking mechanism when it gets up, because you really want to take your foot off of that so you can handle the bottle. And so this one kind of went out the door there a little bit. So then I kind of modified my thinking there, and I said, oh, hey, I just built this hydraulic toe jack. Why not use that same principle, right? And have a part that the bottle sits on, and then a guide post and then you know, the jack would sit in this area here, and then push up against that and lift this up, and then it would just stay while you you know, mess around with the bottle and take it off and put it on the welding machine. So okay, so yeah, all right. So you know, I got to form some pieces or make them up so they fit this nice, and yada yada yada. So you know, I wasn't in love with that idea either. So then so this one's got a bunch of stuff on it here. So I started thinking about a swinging thing, you know, where it would lift the bottle, then you would swing it into place. That way you can project over an edge, right? So you start here with the bottle, and then you swing it in, and now you have you know, a potential overhang, you know, where you can get in closer to where the bottle's going to be, and you don't have to handle the bottle so much. So yeah, I didn't like that much either, because it's a static thing, and I laid it out, and I didn't like the way it was looking there. So it started to change here. This is actually fairly representative of the lift mechanism, although it's inverted from how it's going to be. And then once I started getting the idea, I was making a little parts list, and I'll show you some of the parts here in a little bit. So anyway, that's kind of the chicken sketch part, and then I'll show you some of the AutoCAD layout. All right, so continuing on with the design. So I took some measurements in the bottle, and then this is a potential base layout that I was looking at. You know, and I'm thinking about, is it square, is it round, those kinds of things. And this is the start of the part of the idea here, where I have the pipe sizes for the lift mechanism. I'm starting to look at that, and let me flip this over here. And then, you know, this is just a quickie little sketch here. It's starting to develop here, right? So I got some wheels, then I got the lift, and then the lifting mechanism here. And once again, this is just kind of conceptual sketching here, you know, just thinking about it and just working it out on paper, and making those little bets that I was mentioning, and trying to get it kind of pinned down. Well, here it's really starting to mature here. I'm actually starting to put dimensions in, and I've really changed the tune of the whole thing, and now it's starting to look like a hand truck. And ultimately, this is kind of what we end up with. So here's the lift mechanism. We have telescoping tubes here, a lead screw with some nut mechanism. You know, the part that the bottle sits on here, 1/4-inch plate. You know, 6mm plate. We've got some wheels. We've got bottle support. Okay, it's really starting to harden up here, and I think that's it. Yeah. And this is kind of what the computer layout reflects here, and we'll look at that in a minute. So you know, anyway, that's kind of the progression there of the whole thought process, I guess, is what I'm trying to illustrate there. So how you get started with an idea, how you start working on the idea on paper before you get out into the shop and cut a bunch of metal and then work yourself into a corner and lose the bet, so to speak, or lose the game. So and have to do something odd or non-standard, or you know, you need a bearing that'll hold 10,000 pounds now because you didn't leave enough space because you didn't think it all the way through. So those are the kinds of things that happen when you know, if you don't kind of work out all the details initially up front. Okay, so here's the current state of the art, or well, state of the union here on this bottle lift. So this is just AutoCAD here, and let's just zoom in on a little bit there. And what I've done here, this will be the bottle here, and you can see that rounded corner that simulates the bottle. So what it's really developed into is something that looks like kind of a hand truck, and this is a wheel here. So I figured, I said, well, geez, if this thing's going to be laying around the shop, not being used most of the time, I ought to be able to use it for something else, right? And if it's going to take up space, instead of this big lump of metal in the corner, and you use it, you know, every 2 years or whatever, or every year when you get a new bottle of argon. So I said, okay, well, we'll just set it up so, you know, it can be a little hand truck too, and move bottles around or move boxes or whatever, right? So anyway, this is kind of where we're at here. So the idea is that it has a lifting mechanism here, and we'll talk about that more when we go down to the shop. And so what we do is we secure the bottle to the moving part of the lift. And that's these little points right here, those three, actually they're these guys right here, those profiles there, they nest the bottle. And then, so this is the lifting point right here. And then that ratchet strap that I showed you guys is going to attach here, and basically that red line is approximately the periphery of the strap. And so now what we can do is we can lift. Actually, let me just go ahead and move that. That might be kind of fun that way. Let's move the bottle. Yeah, sure, whatever. So we can lift this. We can lift the bottle up a little bit, right? And then, you know, we can roll the whole mess forward, right? And then underneath here, we've created a little bit of an overhang, right? Well, it's actually right here, but so there's a space under here now, and I can roll this right up to the welding machine. In fact, this can go slightly under the welding machine, so now I can just set this right down into that pocket. At least that's what I'm thinking anyway. So we're going to try that. We're going to build this thing and see how it works, and go from there. You know, like all design projects, you're making little bets and you're guessing, right? So you're betting that the strap is going to hold, you know, and you can imagine that works, and yeah, it's close, right? And you know, you can imagine being able to, while the bottle's raised, kind of scooch this in up to the welder, right, in a safe manner, in a controlled manner, without you know, losing track of anything and having it tip over. So this is what I mean by little bets. So you're making small wagers, and to, you know, to kind of win the big prize, which is the thing works and you're happy with it, right? So that's kind of how I think about this stuff. And this guy here, this is just so, you know, when you have a bottle on there, you can actually go down some stairs or something like that if you needed to. And I just took a look at a regular hand truck and said, okay, let's just add some of those features in there, and you might as well, right? Okay, so anyway, that's kind of the AutoCAD layout, and we're going to go down to the shop, and we're going to make a bunch of junk, and well, a bunch of stuff, and put it together, and then give it a try. So I'm getting ready to cut some tubing here, and I just wanted to show this deal here, because this is something that I've changed in the last couple of months. I have a metal chop saw. It's a Black & Decker, and it's, you know, it's designed for cutting metal, but it's got some problems, and I've never liked the thing. Mainly it's the vise attachment is really weak. It's made out of stamped sheet metal, and then if you have to do miters and things like that, it's crap. Okay, sorry, it's crap. So anyway, I just generally don't use it. It's got a gigantic motor on it, super powerful, you know, and the only thing I really use it for is if I have to cut like hardened shaft or something like that. Anyway, you never see it because it's put away most of the time. Well, not that long ago, I ended up with a second wood miter saw, and it's just a 10-inch, and it's a little Delta, you know, it's on this movable cart here. but the interesting part is my wife was doing a project recently and had to cut a bunch of 1-inch tubing up, 25mm tubing, and you know, it was thin wall, so I got on the recommendation of somebody else that had tried this, an abrasive disc for this. And since I have 2 of these, it's like, you know, no harm done if this one gets messed up, right? So I went ahead and put that abrasive disc on there. Well, anyway, it turns out it works really good, and it's got enough power. And most importantly is when you do your miters, it's got a very, very convenient mitering setup. The Black & Decker, the whole vise has to swivel, so this long length of tubing that you're doing either has to swing or you have to turn the saw. It's just a headache. So the tubing stays, against this fence here, and is supported by these side cables here, which is great on this cart, right? So, you know, I can go back and forth between miter, no miter, you know, with no headache. Now, it's got plastic guards and stuff like that, which are, you know, not optimal for cutting metal, but hey, it works great, okay? And she cut a bunch of tubing, and you can see there's just a little bit of buildup on this, and you know, we took off it's got a sock on the back, you know, for catching sawdust, so we took that off. You know, you don't want a fire back there, but it works good, and you know, you can totally hold on to the tubing here just like you would cutting a 4x4. You know, I mean, it works great. Anyway, I recommend it. You know, get a thin cutting disc, and then use a little dressing sticks once in a while to clean these up, and they cut real free then. Anyway, this tubing for this bottle lift, I'm going to go cut this tubing now. I'm not going to video that. It's pretty, you know, it's cutting tubing, okay? No magic there, other than, you know, this is kind of a different setup than you normally see. Anyway, I just wanted to show that. So, okay, so got a bunch of the pieces cut, and I just wanted to describe the lift mechanism a little bit. So what we got, this is the lift part of the device. Make sure you guys can see all that. And this is an inch and a half pipe, not inch and a half tubing, inch and a half pipe. And this is 1-inch pipe. So this is, I don't remember what the OD is of inch and a half pipe. It's 1.6 inches, about 40 millimeters, something like that. And this is 1-inch pipe, and it's about 1 5/16 or 32 millimeter, something like that. Okay. Now, the interesting part about these two sizes is they make a good telescope. So if you want to make a stand or something like that, this is you know, it's a pretty good fit. You know, it slides together easily, but it moves freely, okay? And these are just stock sized tubes. And finding a telescoping fit like that is always kind of a tricky thing. So anyway, this is going to be the lift part of the setup. And what there'll be is a lead screw inside here. And I bought some, these are silicon bronze nuts here. So I'll have a steel screw running on a silicon bronze nut as my lifting device. And then I have some little needle thrust bearings here and hardened washers to take that vertical load so that the thing runs smoothly. So I've done this before with good luck with these little cheap, these are real cheap thrust bearings from McMaster Carr. These are about $3 a piece. These are about $1 a piece, the hardened washers. And then these are threaded clamp collars here that the thrust bearings will bear against. And but I'm going to zoom in on all that, and you guys can see all that as it develops. And then these are some of the miter pieces that I cut with the saw. So we're going to start sticking that stuff together and building this thing up. All right, so we're going to turn the plugs that go in the lift tubes. And here's just a quick sketch of what they look like. They're just these slip into the end of the tubes and get welded in there. They're going to be made out of steel, and there'll be a bushing pressed in that one, and a nut gets welded to that one. So let's do some lathe work. All right. Face the end there, and then the first shoulder is at a 1/2 inch. I'm just going to go up, and I'm just going to make a little witness mark there, like that. And let's get our initial measurement here. 457. What's my number? Oh, 95. I better be careful there. Better be careful. Let's do that. All right. See what we got here now. Okay, 410. Yeah, 410, and we're looking for 395, 15 thousandths. I'm going to stop it right there, and let's give this a little, I don't think I can quite, the tool holder's in the way. And this tube's got the tube's got a little seam in it too, so oh yeah, I think that's gonna go fine. Alright, we're gonna leave that. The idea of the tube has a little bit of a weld on it, so we'll have to take that out. Alright, let's do a little ID work here. So I got to make two pieces here, so one for the other tube, so I'm just going to over drill it a little bit with this drill. knowing that I'll be able to use that pilot hole again. Alright, that's probably enough. Alright, I'm going to slow this down. Let's see here. It's too slow. How about that? Sure, why not? Doesn't look too bad. That ain't gonna go. Alright. Do this. I'm just gonna measure up to that shoulder real quick. See what we got. 683. I need a little more. I want this 750 through there. Do that again. And see, I'm holding it flat on the bore, and then I'm just measuring to the corner where the drill went to. It's okay, that's plenty there. And then the next operation is we're going to go ahead, we're going to ream that because we're putting a bushing in that particular hole. Grind me a pound of that. Okay, that's it. Okay, that looks all right. I'll do a little chamfering, and then I'll just part that thing off, and we'll call it good. All right, let's part this sucker off. brush is getting all flared out. It won't reach in there. Alright, so here's the nut boss, and that's going to get that on top of it like so, and that'll get welded on top there. It is tack welded so it doesn't turn, and that fits in the smaller tube. And then this is the upper one. This is the thrust boss, and this bushing will get pressed in here, and the thrust bearing will bear against this surface here and do the lifting. Alright. And then there's my little chicken sketch that goes with it. Alright, so we're going to go ahead and put this in. Get it ready for welding. Okay. And then this is the silicon bronze nut. And I'm just going to use a bolt to pilot that to help center that up over that, and then I'll put a little bit of weld on that to keep it in place. So this is the lower tube, and the lead screw will work against this nut here. Alright, so we're going to weld this tube in here. Not going to need much. Couple little spots like that will do it. And then we'll put the nut on. All right, so let's get the nut tacked on there. I'm just going to weld every other flat here. Okay, and then when I weld this, I don't want to leave this bolt in there because it may may stay in there forever. Let's get that out of there, and let's get a little weld on these things. And this is a silicon bronze rod here, by the way. Make sure that's still in the frame, yeah. let that cool off and go on to the next thing. Okay, so this rusty old piece of plate here, this is going to be the kind of the tongue of the bottle lifting cart. So like a regular hand truck, I want to put a little angle on this leading edge so that if I use it for boxes or roll the bottle up on here, I got a little ramp. So I'm just going to machine a little angle on that. And to do that, I'm going to use this little angle plate. Some of you guys have seen this in the videos before. So it's just going to be a quick setup here. Nothing, no indicating, nothing fancy. So I'm just going to use this electronic level here. And I'll set that in that axis there. And I'm just going to hit the alternate 0 here. And that zeroes that up. And so now when I put this in, try to knock all the chips out of there. That goes there. So I'll set that on top. And I calculated the angle, it's about 7.5 degrees. It was actually 7.4 degrees. Okay, so I'm sitting on 7.4 degrees. I'm going to lock that down, and it's staying. And then I got some little jacking screws. I'll put a plate under there and just run those down just to take that load. And then I'll just clamp this on like this, line that up with that front edge, and then we'll come by with a face mill and just knock that off. So that's how that's going to go. Let me get it set up and then we'll machine it. Alright, so now I got a scribe line on here just so I know how far over I want to go. So I'm just going to blend that cut right up to that scribe line, which is 1 inch off of this this front edge. And we're using this Ceratip. Can you see that? Well, it's just barely in the frame. Okay, so it's like 1200 RPM. It's going to come down till it touches like that. All right, and then I'm going to crank in a little bit with the knee. And we'll go ahead and take a pass. I'm going to only cut one direction, that way the chips shoot that way and they don't shoot towards my nice brand new camera. got about 30 thousandths to the line, a little less than a millimeter left to the line. Yeah, one more pass will do it. It's not really, it's nothing precision. It just, it's a lot easier than grinding it on there with a sander, you know? So, alright. Yeah, that works. I'll go with that. Now this is this Ceratip, I don't know, what is it, 1¼ or 1.5" diameter, and it uses TPG 322 Cermet inserts. And they're just flat inserts, no chip breaker, but they can take this hot impact type cutting in stride. And they last a long time, and they leave a nice finish on steel. So I'll zoom in and you can see that in effect. All right. Let me reset the camera so you can see. Alright, so there's the cut that's left by that. Alright, so that's our leading edge on that. Then I'll round these corners a little bit too. Alright, so what we're doing now is these are the bottle support plates, and I need 3 of them that look like that. And so what I'm going to do is I got 3 plates kind of roughed out here. I'm going to tack weld them together and make them into one. And then I'm going to use this spray mount to stick this drawing to it. This is a full-scale drawing. I'm going to stick that on there, and then center punch and drill and get all my holes in there, and then bandsaw that profile out, kind of all as one, and that should save me some horsing around there. So get that out of the way, get that tacked up. They don't have to hold much. They just keep the plates in registration with one another. All right. So clean that off, and I'll spray some glue on there and get it going.